So we have Chapter 3, Section 2, Reinforcement. So you're going to put this information on a piece of lined paper, and we're going to submit this by Friday. You're going to take a picture of it, just your information. If you want to copy off this worksheet, print that off and fill that out, that's okay. But you can just do it on lined paper. I'll show you that here in just a moment. So for question number 1, how much force is needed to accelerate a 1,000 kilogram car at a rate of 3 meters per second We're going to ignore this. The first thing we look at is, what are we trying to find? We're trying to find the force. So the force is what we're trying to find. We know that force is equal to mass times acceleration. Well, that's up here. It showed us that. So now that we know we're trying to find force, we go back, we look at the problem. It tells us that this is the mass and that this is the acceleration. So now we can put the mass in at 1,000 kilograms times 3 meters per second squared. Once we multiply that, 3 times 1,000 is 3,000, and that gives us the units of kilograms meters per second squared. Last video in section 1, we discussed how this right here is equal to a Newton. And so we're going to say that these forces, we're going to measure those in newtons, and a Newton is equal to a kilogram meters per second squared. So there's your answer for the first one. Number 2, if a 70 kilogram swimmer is pushed off a pool with a pool wall with a force of 250 newtons, at what rate will the swimmer accelerate? So we're trying to find A in this case. And so, yeah, we know this. If we know our triangle, then we're trying to find A. We cover it up. Acceleration is equal to force over mass. So now that we know that we're trying to find acceleration, we have to find our force. Our force is the newtons. You need to understand and memorize that newtons is the force, kilogram is mass, acceleration is going to be meters per second squared. So there is some memorization here. So 250 newtons is the force that goes on top. The mass is going to be on the bottom. Well, what's the mass? This is the mass. So 250 divided by 70 kilograms, that's going to round off to at least 3.57 newtons per kilogram. These didn't cancel out unless we know that what is a Newton? A Newton is a kilogram meters per second squared. Remember that up there? So if we brought that down, what would cancel? The kilogram would cancel with the kilogram, and so you would end up with a meters per second squared, which makes sense because we're looking for acceleration. Let me move this up. Next. A weightlifter raises a 200 kilogram barbell with an acceleration of 3 meters per second. How much force does the weightlifter use to raise the barbell? So we're trying to find force. We know that force equals mass times acceleration. We go back and we read this. This is the mass. 200 kilograms is our mass. Acceleration is 3 meters per second squared. So we write this down. 200 kilograms times 3 meters per second squared. So we multiply those. We end up with 600. 600 kilograms meters per second squared. Those are the same units as newtons. And that makes sense because force is measured in newtons. Moving down, number 4. A dancer lifts his partner above his head with an acceleration of 2.5 meters per second squared. The dancer exerts a force of 200 newtons. What is the mass? So we're trying to find mass in this case. If we're looking at our triangle, we're trying to find mass. We cover it up. Force divided by acceleration. So mass is equal to force over acceleration. You need to write that down. Find the force. Make sure you find the force. It's going to be the one with the newtons. So this right here is our force that goes on top. Now we can find the acceleration. It tells us that this is acceleration. That goes on the bottom. So 200 newtons divided by 2.5 meters per second squared. 200 divided by 2.5 is 80. Didn't cancel out until we realize that newtons is what? Newtons is kilogram meters per second squared. Well, the meters per second squared is going to cancel, which makes sense because mass should be in kilograms. Moving on to some other types of questions. What does Newton's second law of motion state? A net force acting on an object causes the object to accelerate in the direction of the force. Now this is an unbalanced force, a net force. So if you have 20 newtons acting on an object, let's say this is a box, and another 20 newtons acting in the opposite, nothing happens. There is no acceleration, there's no movement. However, if we take a different object, okay, a different type of box maybe, let's push with a force of 15 newtons and 10 newtons. Well, the net force, this is pushing 10 this way, this is pushing 5 this way, it's going to actually have a net force of 5 newtons. If that is going to overcome the friction of what it's sitting on, well, guess what? This will move. That is Newton's second law. Which direction is it going to move? It's going to move in the direction of the unbalanced. Remember, unbalanced force is the same thing as the net force. So there we go. Number 6, what two factors, let me move this up. What two factors affect the rate of acceleration of an object? Well, if we know that force is equal to mass times acceleration, well, acceleration is equal to what? Acceleration is force divided by mass. Well, what are the two factors that affect acceleration? Force and mass. So the two factors are the size of the force and the mass of the object. So those are the two different things. You could even put in the direction of the force if you wish. Number 7. Number 7, make sure this is on my video. If you push on a wall with with a force of 200 newtons, what force does the wall push back? Does the wall move? That's the big question. If you are standing and you are pushing on a wall with all you got, and that wall does not move, I don't know if you got a broken leg there or what, but if you're pushing as much as you can on that wall and that wall does not move, then if you're pushing with 200 newtons, how much does the wall have to be pushing back for no movement to occur? An equal amount. So if the wall does not move, then the wall is pushing back with an equal force of 200 newtons. Okay, so the way I want this done, the way this should look, is something that should look like this right here. So you need to have your name, what period you're in the ICP class. This is going to be due on Friday. So on Friday, I will have in Google Classroom a place where you will take a photo of everything you've got, and you're going to add it as an attachment. And this whole thing should be neat. I should be able to read it, and should look just like what we just put in here. It should have a title on it, Chapter 3, Reinforcement, Section 2. So number 1 should look like this. There's number 1, should have a 1. It said force equals to mass times acceleration. Force is equal to that, this is everything we've just went over. So this is kind of what I want it to look like. By the way, I should have done this yesterday for last video on Section 1. So your Section 1 should also look like this. So then we'll talk about this a little bit later as we submit these. This is the end of video 2, Chapter 3.